Another interesting session of this course. And in today's session, we'll be talking about some visualization techniques. And as I discussed yesterday, we have already worked on Pandas and the NumPy library. And today we'll be talking about Matplotlib and Seaborn library. And with those libraries only, we'll be designing variety of charts and plots, etc., by utilizing a CSV data file. So I have already shared a data file with all of you. I hope you have already received it from WhatsApp group. And there is one more file that yesterday I have already shared with all of you that we have already used, that is your heart.csv. So depending upon the time available with us, first I'll start with the today's shared file, that is your healthcare dataset file. I'll start with that first. And if time permits, we'll get back to that heart.csv file as well. And I'll show you some plots with that file also. So the very first task for all of us is to bring that data file on Google Colab platform. So I'll go to the files section. As you all know, we'll just move to this file section, and here we will keep our data file ready. So either you can use drag and drop or upload, any of these techniques. I can upload it by clicking on upload button. So for instance, I'll keep both files ready on my Google Colab. Depending upon if time permits, I'll be using both. Otherwise, one of these I'll be using, and other you can do as a practice later on. So I'll just keep them available in this section. After this, the very first task I'll insert here is import necessary libraries. So 2 important data science library we have already covered, and 2 more we'll be doing today. And we'll first import all those 4 libraries on the platform, because the ones that we have already covered, they will be also utilized in between. So let us first keep all of them ready on our platform. So if anyone remembers how we import libraries on the platform, you can just guide me with the syntax. Just a quick task. Just tell me how I can import NumPy and Pandas. Great, I can see one response. Great. So we can start with the same technique. Pandas as PD and then NumPy as NP. These 2 we already know. And 2 more I'll be adding further. So one is your Seaborn as SNS. This is same as the pattern we have followed earlier. So Seaborn library, I'll give it a nickname SNS. And one more that we have, for this we have matplotlib.pyplot as PLT. So in this library, we are moving into a specific section, basically. We are not taking matplotlib library as it is, but the pyplot section out of this we are considering, and we are calling it with name PLT. This is how generally we use matplotlib library for any kind of data analytics task. So I'll run this, and we'll make all these libraries ready for us. I'll also create code share window for all of you, and we'll keep updated all the codes in that section. So I'll put these libraries here, and I'm sharing code share link also in your Zoom chat box. All of you can get this code from there. Now I'll go to the next step, load dataset. So for instance, I'll create 2 variable, df1 and df2. For the 2 data files that I have, first one, as I told you, will be using healthcare dataset, and second one will be using Heart CSV. So based on what we have learned yesterday, how we can load a CSV file using Pandas, that you will give me here. Just quickly give me syntax for the first sequence. I can see one that looks fine. And similarly, we need it for the second one as well. So I'm just putting the same code right here. And on the same pattern, yes, we can put the heart.csv as well. So this is good to see that you people are now getting friendly with the language, and we are updating it right here. So I can get the green tick ready. So means both the data file are now available on our platform. So one more task based on what we have learned, just revisions we are doing side by side. Check heads of both data files, or precisely we can write check first few lines of both data file. So if you have to do this, what command you can use just to check first few lines of both data files one by one? Yes, very good. So df1.head will be using, and I'll just run it here. We can visualize this is your first data file, and these are variety of elements inside. So this is basically a summary of patient details. You can see the patient information here, their age count, gender, then blood type, then for which medical condition they have visited hospital, that information, date of admission, who was the doctor who treated respective patient, their name is also available. So this is again a publicly available data set. It is not like taken from any specific hospital. It is again a publicly available data set. So we are not violating any like personal information related uh, rules here. This is available for research, so that only I'm using. So insurance provider details you will find, billing amounts are there, and many other details relevant to hospital admissions of the patients are available that we can use for the analysis. And the other file that you already know, this one we have already used in yesterday's session, so that is in this form only. So you know better about this file because we have done several analysis on this file yesterday. One more task for revision I can add here. Check column names from df1 data file. Can you check column names? Just quickly extract column names from df1 data file. Yeah, df1 dot columns, very right. Now we'll write it without brackets. That will all work fine. This form becomes a function. So this columns is basically a method, not a function. So without bracket, you are able to use it as it is. So that I have pasted here, and you can observe these are different types of columns available in our data. Now let us start further. I'll put it here, and the first sequence will start with visualizations using healthcare dataset.csv. The first sequence of visualization we are beginning with here. So I'll use this matplotlib and seaborn one after another in sequence, and we will just try to understand how different types of libraries can assist us with easy plotting sequences, like a variety of plots that we can create and what kind of analysis we can do. All those things we are trying to check here quickly. So it is important to mention first that in Python, we can have hundreds of different types of plots. There are unlimited visualization libraries that you will find in this platform. But depending upon what type of analysis you are doing, what are the available variables, and how your hypothesis goes with that data, you may choose different types of plot for different purposes. I'll start with the very first one. I'll just create some random objectives here, and based on that, we'll start creating plots. So first I'm creating is, we will check age distribution of patients, for example. And for this, I'll be creating here histogram plus kernel density plot. There are technically several different names assigned to the plots that we can have with data. So currently we are having age distribution of patients we are trying to check, and for that the plot type I'm using is histogram and kernel density estimation side by side. So a combination of these I'll use on a single plot. And to do this, first of all, I'll use matplotlib. We can use these plotting libraries parallelly also with each other. That also works fine. So the figure settings, first of all, I'm doing with figure size is equal to maybe 8,5. This is size of the figure that you are creating. This is just a random number I'm passing. Later on, you can try with different numbers and you can see how the size of entire figure varies in that case. Depending upon how many variables you are going to print on your chart or plot, you can change size of your figure. Then from Seaborn library that we have called as SNS, you can observe whenever I put a dot after certain library, it will always give you entire list of functions that are available within that library. You can always see. This is one benefit of Google Colab. It gives you entire list of possible functions inside that library that are quickly accessible. So either you can choose your options from this list. For example, if I have to create histogram plot, I'll choose histplot from here. Or if I know the function already, I'll type it as it is. So histplot I'm writing. And there are some specific set of parameters that we may need to pass inside. I'll write here df1, and because I'm plotting it for age variable, I'll pass here age variable. And similarly, KDE, because I told you that I'll be creating histogram with kernel density estimation. So KDE plot, I'll make true along with it. Then further, I'll add here plot title, that is age distribution of patient. This is the title of my graph. Then in order to make our graph more easy to understand, we will add labels for x-axis, then label for y-axis, that is your count, and ultimately we will display this plot. So this is plt.show. These are few essential things. First, I'm just setting up figure size. Then I'm putting information about what type of plot I need and on which variable I need to deploy it. Then title of my graph. Then names of x-axis and y-axis that should be displayed on the graph. And ultimately, we are asking it to show that plot. So if I run this, you can observe here, this is the distribution we are getting for age variable that we have in our data. Observe here, the count, this side is showing your count. So a very huge count up to this we are able to get. And this is your age distribution. So for few age groups, there are like a smaller number of entries, but majority of time they are almost equivalent on the top. You can see some areas are already touching the top portion. So the count of patient age groups we can see from here. So this can give us an idea about what is the common age group that keeps on visiting that particular hospital from where they have gathered this data. So all of you can try creating this graph. Okay, this KDE that we are talking about here, you can observe we have these two types of plots here. One is these bars that you can see, and one is this soft line, this continuous line that you can observe. So these bars that we can have, this is your actual histogram. Histogram is a combination of bars, basically. We call them bins also, a combination of bins. And this continuous line that you have, this is also showing the similar kind of thing, but not with bars, rather with these soft lines, like line chart type distribution it is showing. So if you need an observation with this kind of soft curve that just shows the continuous variable distribution for you, you can go with it. Otherwise, you can even make it false. You can see, if I make this portion false, then only bars will appear. That soft line will not appear. That is showing your overall distribution of the age group variable. So this is up to us whether we want to make it true or whether we want to make it false. So in that case, both plots are coming parallelly on the same graph. There is one more option, like the histograms that are represented with these bins over here. These are default number of bins that your library is selecting for the display of your age variable. But we have a control to change these bins count also. If you want to change representation of your variable, like maybe I can say that to represent all these age groups, I need only 20 bins. So if I change this parameter here, it will display this distribution within 20 bins only. You can observe. Then it will display with smaller number of bins. Earlier, it was taking larger number of bins depending upon how we are just distributing the entire age variable. So there are plenty of things that are available as free control variables in your Python environment. These libraries assist us to create variety of changes into your plots as per the requirement. So I have just updated this one plot code in your CodeShare window also. Run this and let me know if this is fine. Yes. So SNS and PLT can talk with each other by default. There will not be any problem in that. So they can take reference from each other when we are just putting them together. So the plot informations, they can pass to each other automatically. So I'm sharing CodeShare link again in the chat box. You can find it from there. I'll take it to the next plot here, for instance, one more plot I'm creating. Maybe we want to see patient count by gender. And for this, I'll use maybe bar plot. I'm just taking few different types of plots. Later on, you can try changing them with different variables. I'm just giving you a quick idea about what are the possibilities right now and how you can choose those type of plots. So I'm creating patient count by gender variable now. And for this, I'll be using a sequence with df gender I'll use. I'll calculate unique values from this first of all. And I'm using here the yesterday's technique, if anyone remembers, the plot technique we have used yesterday. So that one I'm using here. Type of plot I'm passing is bar. And in this one more parameter that yesterday we have not used, just to create colorful plot, I'm passing one more parameter that is color. And because I know that in this gender variable, we have two different parts. Like if you want to check it earlier, you can just pass it here and just to see the distribution. So we know that these are the male and female categories available in our data set. So based on this, maybe we can create two color planes for distributing these variables. So I'm just putting few options for the color variables. There are a range of colors available that are accepted in Python environment. So I'm using just two random colors right now. You can try others like red, green, blue, etc. different colors. Then the remaining details, that is for title, I'll write here gender distribution, for example. And then I'll put here X label, that is your gender. And then we have Y label, that is number of patients. And then plt dot show I'm passing here. So these are the basic points that we have already learned. The same I'm using. Just in this case, I'm first counting this distribution. And then for this male-female distribution, I'm trying to create a plot. And the plot type is bar chart. And for these two entries, male and female, I'm passing here two different colors. So first category will take sky blue color, second category will take salmon color, and accordingly that distribution will be presented here. You can see. So male female category, because they have almost equal number of entries. So you can see these bars are almost close to each other. However, if you have some other data file in which the distribution is very different, like we have seen yesterday's hot CSV file also, so in that case, the distribution may appear with different bar size. So I'll share this one also here in your code share window. Try this one also and let me know when your graph is done. Based on what variables we have in this data file, I'm just creating different objectives for the graphs right now, but later on you will be defining them based on your research objectives, and you can club variables based on that only. Let me know if we are all on the same page. This 8.5 is representing size of your figure. This graph you can see. So its dimension basically we are setting up. This is the basically size of your figure we are defining towards x-axis, towards y-axis, how the dimensions will expand. You can change these values, and based on this, you can see how size of your variable updates. KDE we have recently discussed. This KDE is this soft line curve. Along with the bar chart, I'm seeing this soft line curve also. So this kernel density estimation helps us to see the density plot basically. So wherever you have a larger number of entries, this density will be on the peak. And for the lower number, this is coming down, you can see. So this is kernel density estimation basically. Either you can use bar chart or you can use kernel density estimation to see how your variable is distributed in different count. Let me know if you are done up to this, if you are ready with the gender distribution graph. Now I'll pick up some more variables for creating distributions here. Like for instance, I'll take this one, medical condition variable I'll take for instance. This one we have. Let us see distribution of medical conditions, like the patients are visiting hospital. If you want to see which distribution is more, which is less, like which type of patients are more commonly available in this hospital. So that also we can observe. And for this, I'll be using count plot, for example. Count plot is one of the most popular type of plot used for distributing categorical variables. And you can observe that this medical condition is also a categorical variable. I hope all of you can identify it. So depending upon what type of variable we have, accordingly the plots we can select. So I'll choose here the next task. Here I'll write third plot, distribution of medical conditions, and that I'll do by using count plot. There are so many different ways to create count plots in Python. I'll just use one technique here to assist you with the format. For example, first of all, figure size I'll set here. this figure size setting is generally optional also. That is important to understand. Even if you don't pass figure size setting, your graph will take certain size by its own. That is, default setting is always available in your system. But sometimes if you feel like that default size of the figure is not suitable for my type of data, you can pass this figure size information with your customized values in that case. Otherwise, this line, this first line, you can skip, that we are using here, because by default also certain figure size it will always take. So count plot we can take from SNS, and count plot also appears more like a bar chart because it appears in the form of bars only. But that is a better choice for any of your like when we have to represent categorical variables, whether a single categorical variable or a combination of categorical variables you have to present, then we use count plot. Sometimes it appears almost similar to bar chart, and bar chart is available directly from the plot function that is associated to pandas. And this count plot I'm taking from SNS. So there are several functions that are available in different libraries, and they can help you create similar type of plots. But this is up to you which library you find more easy to operate. You can go ahead with that. So currently I'll pass here the count plot information, and inside this I'll write first of all data equal to df. The count plot will require different entries. First it will need which data you are using. So currently name of my data is df1. I need to mention what I have to pass on x-axis or y-axis. So maybe the variable I'm passing on y-axis, you can put it on the x-axis also. I'll show that also to you later. So maybe on y-axis I'm putting this. First, let us see if I run it in this form only. You can observe this is the distribution we are getting. Observe carefully what I have done. I have just mentioned that which data I'm considering for count plot operation. And then from that data, the medical condition variable I'm passing on y-axis. So accordingly, it will create across y-axis. You can see this is our medical condition variable. It is showing this across y-axis, and on this side, it will automatically take up the count, because count plot is for plotting count of the categorical values. Similarly, if I pass it against x-axis, observe I changed y to x. So if I run this, now we can see this type of bar chart. Now this medical condition is on x-axis, and your graph goes with reference to the count towards this side. So in this particular data set, majority of values in different categories appear almost similar, because this is a kind of balanced data set they have created for common research for the students. But in majority of time when you get data set from real hospital environments, they may have a very difference in your patient count in different departments. It is not like everywhere you will have similar number of patients. But yes, with this data, this is a distribution we are getting. However, slight change you can still observe. Some values are still up and down, very small difference, but still there is a difference. So let me just show you one more interesting thing. Like currently, all of the bars are almost similar. But in some cases, if you have like maybe a major difference between bar size, and if you want to show it with respect to the count, like for instance, in this case, your arthritis count, this looks on the top, and this diabetes count, this also looks on the top. So these may have higher number of values. And this one, the asthma one, this may have lesser number of values in comparison to others. So if you want to see it in maybe any specific order, like higher first, lower after that, that kind of thing is also possible. Let me just give you a quick idea how you can do that. Maybe I'll take up this same thing. Observe, I'll share this one also with all of you side by side. So I'll just modify it slightly. Currently, you can see cancer is first, arthritis is last. So I'll just change this one. And here, I'll pass order variable also. And in that order variable, I'll mention that we have to consider order based on the medical condition variable, and that will be calculated based on the value counts. Value counts function you already know. So based on the value counts, for instance, if I calculate the value counts, let us observe everything side by side. If I observe value counts from the medical condition, this is currently the count we can see. This one is the highest, this one is the lowest, although very small difference, but still there is a difference in numbers. So what I'll do is, when I check this value counts, if I ask you one simple question, which one of these variables is having starting index in the storage? Like if I store this sequence, which one of these will have starting index from this list? Indexing we have done several times. If anyone can give a guess, which ones are on the starting index and which ones are on higher index? Anyone? Okay, no responses. Observe here, when working in Python till now, I have shown you that index values are taken up automatically by your programming system. So there are generally two different index types also available in Python. I have already shown you that with your positive and negative indexing, that we have already learned. But this belongs to system index basically. This positive and negative indexing belongs to system index. System index means when the index values are assigned by the system itself. Like you need not to pass any specific index element in that case. So it will automatically take like starting from 0 in case of positive indexing, starting from -1 in the negative indexing case. But there is one more case, that is user index, where we can assign specific variable or names for indexing. In this case, indexing we can do as per our choice. That becomes user index also. So sometime we assign a specific variable itself for the index. And how does it appear? Observe here very carefully. This medical condition right now is working as an index element, that is user defined index, because I'm working specifically for medical condition variable here. So it is considering this as index element, and this count, you can see the position is different. This is slightly higher, this is slightly lower. So this lower one represents your index of the calculation that is present in this table. So this is the first index value, this is the second index, this is third index, and so on. Let me know if this point is clear, that how user index may appear. I hope I'm audible to everyone. I cannot see any updates in the chat box today. We don't have any custom index right here. I'm talking about two types of index. One is system index, one is user index. System index goes automatically, starting from 0 or -1 in the negative side. User index goes as per either if you have assigned a specific variable from there. In the current case where I'm using this value counts variable, this goes as per the higher one. Like automatically it is taking higher to lower. So whatever is in front of higher value, that becomes its initial index. Then this is the second level, this is the third level. So in that case, based on the calculation, it will assign user index. Sometimes we can even choose a entire variable. Like I can make this name also a user index. In that case, instead of these zeros and ones that are coming by default, these are your system index basically. In that case, this will go away. Rather, this name will start appearing with this bold here, and that will become your index in that case. So these remaining variables will be considered as normal variable in that case, and this will appear like a user index on which you cannot do any kind of plotting, etc. Then, because that is more like a serial number, this name will appear more like a serial number or serial names we can consider in that case. Or it could be maybe patient ID also, that can also work as a user index sometime. Let me know if the point is clear now. Okay, great. So what I'm doing here, based on this user index only, I'll pass here the index sequence. You can see the order I'm passing as per the index of value counts. So it will take index from here, and the higher one will appear first in the graph now. So based on this, I'll run, and you can see now arthritis comes first, diabetes comes after that. So based on this count, now it will appear. Earlier, cancer was first, obesity was second, and then the remainings were appearing. But this time, it took values based on these entries from the value count itself. So according to that only, these graphs are appearing. So the higher bars are appearing first now, the lower ones are appearing after now. So in this way, we can even control how we want to visualize certain kind of graphs in ascending or descending orders, etc. That also we can do. So there are different types of plots that you can use for this purpose. And I have just shown you a quick idea with count plot for this. I have not currently passed title and labels, etc. But you can do that in the similar pattern that we have done in the previous case. Like I can take all these things and I'll just update it quickly. For instance, I'll insert it here in this sequence, and I'll write here most common medical conditions. And on the x-axis, we have, I think x-axis currently we have medical condition. And on y-axis, we have count in this case. So that only we are displaying here. So now you can see precise labels also on all the axes. So I'm sharing this code also with all of you. And get it done and let me know when you are clear up to this level. For making data values on the top of the bar, you can generally use Plotly library. There are many other libraries also. In that case, you can make interactive plots also. We'll learn that in, I think, in level 2 course, Plotly, etc. In that case, when you hover over bars, so wherever you put your cursor, but value at that point exists, that is also displayed creatively. So that kind of interactive plots also definitely you can create by using specific libraries and their functions. Okay, great. So we'll move one step ahead now, and I'll create here a box plot. I'll take one more example from the data itself. For example, in this particular file, we can have, okay, I'll take this billing amount, for example. This billing amount I'll take, and I'll try creating a distribution for this one. And because this is like a very extensive range values, because this is a figure in lakhs or in thousands, somewhere higher values will be paid by the people. So let us see how the distribution of billing amount is present in this particular data set. So for that, although different types of plots are possible, but I'll try to solve it with the help of a box plot so that you can also learn about box plot side by side. So I'll write here billing amount distribution, and that I'll do with the help of a box plot. And for this, the technique is very simple. I'll take sns.boxplot. On the x-axis, I'll pass df1 with billing amount variable. Just this only we have to pass in actual. Other than this, the figure size, title, label, and show, etc., that is our choice. We can pass that as per our requirement. But in actual, this is your main required code to create any kind of plot. For example, if I run this, you can observe the box plot is quickly created. On your x-axis, you can see this billing amount, and this is your box plot, and this is with reference to df1 variable we are getting here. And this box plot basically is showing that a majority of your billing amount are within this range. This is your required range, and it doesn't show any kind of outliers, etc. Everything is within the boundaries of your data. There is nothing outside it. So this is a common distribution of box plot. I'll also give you a quick idea about what other details you can find from a box plot in general. I'll put it here, the figure that I have created on that graph. Observe here, yesterday I have talked about outliers also. I gave you a little bit indication about the outliers. And in that case, we were also talking about quartile values. I have talked about 25th percentile, 75th percentile, etc. That I told as first and third quantiles or quartiles available in your data. So that kind of setting is generally applied on box plot for outlier directions. For instance, you generally have Q1, Q2, and Q3, out of which Q2 was representing your median that we discussed yesterday. Q1 was representing your 25%, and Q3 was representing your 75%. I have yesterday shown you with this kind of box. Like the middle one was showing your median value, then half of the lower one, this was showing your 25 percentile, half of the upper one was showing your 75% or Q3. This thing we have discussed yesterday. So this box that I have created here, this was basically the same box plot that I have created, but I have not added its wings in that case. So in actual, how this box plot helps you to get information about your outliers. So there are some specific methods available for that. I'll just disclose one simple technique here. The actual implementation of that we will learn further in level 2 course. But just to get a quick idea that how outliers may be detected by using box plots. So generally there are some mathematical formulas to decide boundary values for actual distribution of your data. I told you yesterday that outliers are some noisy observations in your data. They may be entered by mistake, there may be some long range values that are not expected within your data, or anything out of bound that appears in your data that becomes your outlier. For example, maybe if in your case, uh, just taking a random hypothetical value, maybe you are expecting that cholesterol values for any patient may be lying between 100 to, for instance, maybe 450, just taking any random range. Maybe your upper and lower limits are something around these values. But when you check your Excel sheet, you see that in my cholesterol values, there are some entries with -5 value, some entries with 700 value. So these are outside your actual boundary that you are expecting in your data, or that is statistically possible in your data. So if anything goes outside boundary, that becomes your outlier or a noisy observation that you were not expecting in your data, and that is not a part of your actual data distribution, but still it is there. So it may be some manual error, it may be some sensor based error during measurement, or there can be many other reasons behind it. So sometimes we have to deal with these outliers, we have to drop them off, we have to deal with them more like missing values that we did yesterday. So many techniques in literature are available for this. But how box plots help you to do this basically? So in order to identify these out of bound values, there are multiple methods. One of them is IQR method. We will discuss more detail about this IQR method in level 2 course. But for general understanding, this is interquartile range method. And in this, we can decide about lower boundary and upper boundary for outliers. And that is generally calculated. Lower boundary comes from Q1 minus 1.5 into IQR. This is your lower boundary. And Q3 plus 1.5 into IQR. This represents your upper boundary. So this lower boundary and upper boundary basically is represented here. This is lower boundary calculation. This is your upper boundary calculation. And anything if lies outside these boundaries, they are called as outliers. And all the data that is within these boundaries, that become your actual required data in your data set. So first we calculate these upper and lower boundaries by applying mathematical formulas, and then we decide whether there are outliers in our data or not, and then we apply some statistical procedures to deal with those outliers. So this is a general understanding for how we deal with noisy observations in available data. And here I'm just showing a quick information about how billing amount is distributed, and that we are doing with the help of box plot. And that is why I was saying that there doesn't appear any kind of outliers, otherwise they would be visible on these edges of your graph. I'll show that you in some upcoming case studies in level 2. So there you will learn better that how outliers may be visible through a box plot itself. So in this one, now we can add maybe x-axis, y-axis information, or etc. So that you can do yourself also. You can give it a try. But the general plot I have created for all of you here. And you can try this and let me know if the idea behind box plot is clear now. Okay, great. I hope others are also able to do this. So I'll show you one more version of this. Currently, I created a single box plot here for the entire billing amount. Yes, we can do that for multiple columns also. I'm showing that only further. Observe here. Now I'll be creating a box plot between two variables. I'll just compare two variables against each other. And what I'm doing here, for example, billing amount by admission type, for example. I'll write here. So this will be represented with a box plot right now. So I'll be considering two variables. One is your billing amount that goes right here. In order to print your Q1, Q2, and Q3 value, you use describe function. Yesterday we have used that. Describe function shows that for numerical variables. Box plots are available for numerical variables. So from there, it can calculate your 25 percentile, 50 percentile, and 75 percentile, and they represent your Q1, Q2, and Q3. So we are talking about this one. Like one variable I'm taking is this billing amount. This one is the admission type. So I'm creating a box plot between these two now. One is my categorical variable, one is my continuous variable. So I'll be creating a combination of these two. We will just try to check billing amount with respect to admission type of the patient. So maybe like whether the emergency patients spend more, or maybe if it is your elective patients or urgent patients, because there are two three different categories of admission type also. So for this, what I'll do is the general settings that are optional I'll apply. Figure size, for example, I'll put here 10,6. You can change this value as per your requirement. Then I'll pass a box plot, and inside this data is equal to df1. I'll pass. Now I'll pass x axis and y axis details, because this time I'm creating it for two variables. So one variable will stay on x-axis, other will stay on y-axis. Earlier, I was passing only x-axis variable. So on y-axis, it was not considering anything relevant, but it was more concerned about the x-axis, and based on that, the distribution for box plot it was creating directly based on the number of entries available in this billing amount range. But this time, since it is across two variables, so I need value across x-axis as well as y-axis. So maybe on x-axis, I'll choose admission type. You can change your variables also later on. Admission type, and other I'm using is billing amount. If certain type of plot is not compatible with your data variable, then you will definitely get an error. You always keep that in mind, because some plots are suitable for categorical variables, some plots are suitable for continuous variables, and if you try to use them alternatively, you may get sometime errors. So we need to be careful about. With practice, generally you come to know that which plot is suitable for what type of data distribution. So here, if you are working box plot for a single variable, you go with the continuous variable. And if you just want to see distribution between two, then one will be your continuous variable, other will be your categorical variable. That type of selection I'm doing here. Then I'm taking the title, that is billing amount by admission type we are checking. And furthermore, this one I'll keep as it is. I'll use here plot show. So I'll just run this part, and we can visualize these box plots right here. Now we are getting three different box plots. Although they have almost equal distributions, you can observe here, almost equal distributions. Although this is not possible with any real data set, but because this is a synthetic data set available on public platforms, so that is why we are getting almost equal size of box plot in three categories. But at least we are learning how we can create it. So this is for the urgent admission type, emergency admission type, and elective admission type, because they have these three categories in their data set. So we are just comparing it with the amount paid by people. So in this way, three different box plots also we are able to create. I'm sharing this code in your code share window as well. Let me know when you all are done up to this. I'll wait for responses if everyone is good up to this. Then I'll give you a small task. Okay, great. So we have a task here now based on what we learned from the previous plots. I'll pick up any one variable from the list that we have in our data. From this one. Okay, we'll take this blood type variable, for example. This is also a categorical kind of variable. So what I'll ask is, let us check blood type distribution with, generally you can choose a variety of plots, but let me give you an idea what you can do. blood type distribution we want to do, and we will choose maybe bar plot for this. Just give it a try and give me a full-fledged section of code, like title should be there, label should be there, everything should be precisely provided in your graph, because that is your standard version of graph that is required for research or display purposes as well. So create a bar plot or bar chart. You can take references from what we have done till now. I have already shown you how we can create a bar chart. So based on that, for blood type variable, you can do. Take your time and share your code in the chat box when ready. Let me know if anyone is done with it. Great, I can see some responses. So two different responses I have here. One is count plot and other is bar plot. Okay, let us see which one of them works. I'll take the first one here and I'll run this. Okay, that's fine. Although I have not used bar plot with SNS earlier, I have used that with plot function directly, but that's great that you have explored one more type of plot here. And bar plot also looks fine with SNS. Last time, the one I have shown you, that was with plot technique directly. That was this one, that was with plot technique. But this is great that you give it a try to SNS also for creating your bar plot, and you could get a proper distribution of all blood types here. In the similar pattern, I can see here with the count plot also. Let me see. I think they are two different plots that they have created. Let us try both of them one by one. First, we will see with the count plot, and then we can see with bar that is with plot function. So each one of them looks fine. We can observe this kind of distribution. So it is up to you how you feel easier to connect with your graphs or how you want to see distribution of your data. But definitely you have done a great try on different types of functions here, and all of these plots looks very fine. So this makes your plotting task pretty simple with Python. Let us try one more thing. Since you have learned several types of charts and graphs till now. Yesterday, I have shown you one example of pie chart also, I think. We have discussed about pie chart. I created that for one simple variable in HUD dataset yesterday. So let us create one example. Insurance provider. There is a variable insurance provider in your current data set. So we will see insurance provider distribution, for example. But this time you have to do it with pie chart. Just give it a try. We have learned pie chart creation yesterday, and that was with plot function. But if you want to try something else also, that is your call. Just try creating a pie chart to display your insurance provider information. Give it a try yourself. You can take reference from what we have studied in yesterday's session. That may help you. And share your code. This is just for helping you to be more confident with Python programming. That is why I'm giving these small tasks today. Okay, great. I can see one output here. Let us see. I'll run this, and that looks fine. We are able to see exact bar chart over here. Anyone else, if you're trying with any other way? The titles and labels, etc., we can update here. One thing you can observe here, this count is overlapping this United Healthcare, and this is y-axis label basically. So let us remove this count from here to get a cleaner version. So what I can do is I'll write here plot dot y label, and inside this I'll pass empty space. I'll create an empty space. I'm not adding anything inside inverted commas. And then I'll use plot show with this updated information. And now you can see that count is not available here, and I can see a clean plot now. Nothing is overlapping now. So we can even modify certain sections based on our requirement. I hope this part is clear to others also. I'm sharing this code in the chat box. Thank you very much for your quick response in the chat. Okay, based on the information that we have here, let me give you one more idea from the data set itself. Like if you observe this variable distribution, observe here, we have date of admission available for the patient, and we have discharge date. Can anyone suggest what new variable we can create by using these two variables, date of admission and date of discharge variable? If we can create any new variable by using information from these two columns? Yes, the duration of stay or length of stay, we can call that. So a new variable can be created from existing variables in that case. So this is important to understand here, that the format of these variables right now is in the form of date entries. They are dates right now, year, month, and day. That is the appearance. So dealing with date time variables is slightly different in your data frames. We can extract exact date information from here first, and then based on that we can create a minus to calculate exact number of days. I'll show how precisely we can treat these date-based variables instead of counting it manually. I'll write here, calculate length of stay, or maybe duration of stay, you can call it anything, per admission. And for this, first of all, we will observe one thing. I'll check info of my df1 variable. data set. You can observe here that your date of admission in both these sections is appearing like a object entry. Observe this. This is appearing like a object entry, which is not a valid entry. It is important to mention here that dates in pandas data frame have a specific representation. We call that date time representation. If it appears like a object entry, then we will not be able to operate it as a date time information, because from 2024 year, then we have month, then we have day. From that, if it is appearing like a string detail, we cannot apply any mathematical formula on it. That we discussed in the basics of Python also, that on strings we cannot apply mathematical formula. For mathematical formula to be executed, we need it either in the form of numbers, or there should be date time, because it is easier to subtract date to date. Then we can calculate intermediate duration. So first I'll convert these variables. These both variables I'll convert to their standard format. How we can do that? Observe very carefully here. I'll update these two columns. That is your date of admission column. First I'll take pd dot to date time. Observe here, the function name is pd dot to date time. Means from the normal object entry available in my pandas data series, I'll convert it to date time. And this operation we are deploying on date of admission variable. So I'll pass that inside. And after this, I'll check info again for df1 variable. I'll run this conversion from object to date time, and then I'll check info function again. Now observe, this format is changed. This is appearing as a date time format now, which is the required format for my date column. The same I'll do with the discharge date also. So can you try the variable for discharge date, how we can create a sequence to update into date time format based on what we have learned recently? Give it a try. Just a very basic thing only. You just have to change the variable name and update your second variable. Let me know if you can do that. Okay, great. So what we have to do is we just need to change this one. I'll write here discharge date, and here also we will update the same. And we can see the updated variable based on this. So this one is also updated now. Both of them now become date time variable, and now we can do directly extraction of number of days from these variables. So how I'll do that? Observe here. Either you call it a duration variable, or maybe I'll call it length of stay variable. I'll create and I'll store it within the same df1 variable. Means one new column we are creating with name length of stay, and inside this I'll pass df1. Inside this we have discharge date and minus df1. Inside this we have date of admission. So subtraction between these two first of all. But observe, if I subtract them as it is, there are three things. If you observe in your data set, we had three things in that. year, month, and day. But we are more interested in day right now. We need information on day. So what I'll do, I'll make it the extraction specifically for the day. So I'll write dt dot days by the end. So from date time, I'll focus on days only that I'm mentioning here. And after that, I can check my df1 head also to see how a new variable is created and what is mentioned in that. I'll run this, and by the end of this, I can see length of stay. So because this is in days, 2 days, 6 days, 15 days, we can quickly calculate that based on just the date time analysis. I'm sharing this with all of you. Try this and let me know if you can get a new variable like this. This is how we can generate new features from the existing data. Depending upon what changes you want to do, you can just apply that using direct formulas and a new variable will be quickly created. Now for this length of stay variable, you can create any kind of distributions, like maybe a histogram plot you can create, or maybe some other bar chart based distribution you can create. That is your choice. But with this new variable also, now you can do variety of analysis. Let me know when you all are done up to this. I hope everyone is good up to this. Yes, dt here refers to date time. So one more type of plot I'm creating here now, that is line plot, or we call it line chart also. So for this, I'm taking the admission variable, that is your date type variable again. And because there are several entries, if we consider daily collection of data. So if we consider daily, then there will be a very large number of entries. But just to understand the trend, either we can do annual trend analysis or maybe monthly trend analysis. So here I'll use a simple technique. I'll use monthly trend analysis. So for the number of years for which data is collected, it will first extract months of information from every uh, date-based data available with us, and then it will be able to create a trend line from there. So I'm creating admissions month over here, and that will be from date of admission column, and dt dot to period I'm calculating, and that period is for month we are updating here. Just a minute. So I'm passing it for month. So we are collecting period information based on month right here. So because this data includes multiple years, so it will first map monthly data per year. That is why we are writing here to period for the entire duration that it has. So monthly data for every year it will collect, and then it will assure us display of that. And for that, I'll use maybe a line chart further, on this particular variable. Basically, we can also visualize this variable if you want to see first that what it has created. I can create a df1 head over here, and we will see. You can see I told you that with year and month both it will be extracting, because otherwise there will be so many repeated months from every year, then it will not be able to identify which one is from 2024, which one is from 2029, or other entries that we have. So based on that, first it will collect the period based on the month entries, means only days are extracted out, and remaining two things are kept side by side. Now for this newly created variable, I'll create a plot that will be your line plot further. So for this, I'll enter here df1 admission variable, admission months variable I'll take. I'll do value counts for this. Then I'll sort the index. Why I'm sorting index here? That is very important, because annual sorting will be doing. You can observe that in this recently created variable, this is your important parameter. When a line chart will be created, annual distribution may be required in that case. So for instance, if a line chart that appears something like this is created, so there may be a trend something like this, and how it will be distributed, there may be some year based entries. So here at this point you may have maybe 2019, then trend goes further in 2020, then so on. Such trend lines will be created maybe up to 2024 or 2025, and those variables we will see up as your trend line here. So now we need this thing. We cannot have 2024, then 2020, then 2023, any random value. We need to sort it in a specific order so that we can see the trend, how year after year the admissions changed within the hospital. So in order to understand that, what we will do, we will first sort the index based on the value counts that we are having. And then I'm just plotting, and the type of plot I'm using here is line plot, and the marker type, because when we are creating a line chart, there are generally multiple options for a line chart. One option is that you create this plain line chart, and other option is that wherever you are putting some readings, you add a pointer over that place, like for a for monthly reading. So one month with this dot, other month with this dot. So this kind of markers you can have wherever you have the reading calculation in your data. So those markers I'm putting here in the form of maybe a circle. So that circle with a small o we can define as a marker. The other things will be same. The title I'll pass monthly admission trend. Then I'll pass X label for a clean plot. That will be month. Then Y label, we can pass here number of admissions, because the count, basically we are checking monthly count for the line chart. And after this we can show the plot. I'll run this, and you can see monthly distribution, because there will be several months per year. So currently, based on the huge amount of data that we have, it will display only the annual information. But yes, the monthly data is shown with these markers right now. So how many months of data per year it has, accordingly the number of markers are placed in your data. And it goes further. It shows how the data is appearing year after year with the patient admission counts. You can try this to plot with admission months. Give it a try and let me know if this is clear. I'll wait for responses in chat box if you're all good up to this. Okay, great. So now I'll do few more visualizations with the other data set that we have used yesterday. There are still many other variables left in the current data set that you can explore later on with variety of plots. But just to show you a few more ideas, I'll be using the second data set that we have already taken on the top. So I'll write here visualizations using third.csv that we have already loaded in df2 file. So that I'll be evaluating just 2-3 different plots I'll be creating out of that. And the first one I'm taking is, for example, count plot, but this time between two variables. Earlier, when we used this count plot, that was for single variable only. Now I'll show you how you can do with two variables also. So for example, we will see if you just go to that heart disease variable, first of all, I'll display its distribution over here. You can observe these are the variables in that particular data. We have loaded that earlier. If you have not loaded, you can load that. I hope all of you know that. pd.read_csv method you can use to load it. And here we have different types of variables, categorical variables, numerical variables. So maybe I want to see a distribution of chest pain type with reference to heart disease. Maybe between these two, I want to see a distribution. So the task here, I'll add count plot to show distribution of chest pain type with reference to heart disease condition. So for this, first of all, figure size, that is optional again, but I'll pass it and just to ensure a specific size of the chart I can get, 8,6. Then SNS dot count plot I'll create. If you remember, in count plot, we first need to pass the information about which data we are using. Then we can pass x-axis information. So here, name of my variable is chest pain type. Make sure you use exactly same variable that we have in our data. So it is written like this. The same I have used here on the x-axis. Then we have y. And on y-axis, I'm passing the second variable, that is heart disease variable. This is one option, putting it on x and y-axis. But I'll show you one more creative way to do this. We can do color representation also. Like I'll use it with reference to hue details. Hue means color indication. That brings your charts with more colorful details. So it will distribute chest pain type with color of the heart disease markers. And if I try to show this plot, the title, etc., you can add. I'm just showing it quickly here. So you can observe chest pain type on x-axis. And this is the legend for heart disease type color, 0 and 1, as we have discussed yesterday. A healthy patient and the person suffering from heart disease, that those two categories we have here. So these are the details here. So considering that if one represents patients with heart disease, so it shows that majority of patients experience asymptomatic heart pain when they have heart disease. So this one ranking is showing very high. Then typical angina is the lesser one, and there are two more other types of pains that are reported here. So the rank for each one of them we can observe here. So this one pain is more associated with the heart disease cases in comparison to the other cases that we can have here. So in this way, you can have colorful representations of your variables for a better discussion with your peer groups or to put them in your research files. With this, I'll show you one more interesting plot. Observe that generally when you are analyzing different types of variables in your data, You can have univariate analysis, bivariate analysis, and multivariate analysis. These are three keywords you have in data analytics. If anyone knows what is univariate analysis, if you have any idea, univariate analysis. You can post quickly in the chat box if you have any idea about what is univariate analysis. If not, then also let me know. Accordingly, I'll explain. Okay, no problem. So generally, while working on any kind of data analysis, you have three types of options, or although it depends on your objectives in research. Univariate analysis is when you are working on a single variable to analyze its pattern. For example, in this particular plot, we are talking about, maybe if we are, this is not one, I'll choose a single variable plot here. This one, like we are talking about insurance providers, and we are making analysis on that only. Nothing else we are taking. When we are doing the analysis on single variable only, that becomes your univariate analysis. Similarly, when you are analyzing two variables against each other, for example, in one more plot further, this one, I'm analyzing two variables against each other, chest pain type and heart disease against each other. I'm just identifying their relationship with each other. So this becomes your bivariate analysis. And then comes multivariate analysis, when you are analyzing more than two variable or multiple variables against each other, just trying to see relationship of those variables with each other, then it becomes a multivariate analysis. So depending upon your objectives, how you are dealing with your variable, these three different types you can use. And depending upon what type of analysis you are doing, you can choose different types of plots also. Some of these plots are useful for univariate only, some of them will support bivariate analysis, or some of them are suitable for multivariate analysis also. So that is general pattern you will observe in your data analysis projects. So I'll show you one more interesting plot here, that we call, for example, violin plot, which is widely used by researchers for displaying distribution of their variables. And this one I'll use for cholesterol by heart disease. I'll try to analyze. Again, this is a bivariate analysis between these two variables. I'm trying to do this. So I'll write here SNS dot violin plot is directly available. I can choose this. And inside this, I'll pass data is equal to df2 variable. Then x-axis I'll plot is, for example, heart disease. And on y-axis, I'll plot, for example, cholesterol. You can reverse these axes also. That is your choice. And then the title I'll add, that is, for example, just a minute, I'll just update title first. So this is cholesterol versus heart disease, for instance. And that's enough, although we can write plot show also. So now you can see another plot we could create. On the x-axis, it represents heart disease, and then cholesterol for people who are not suffering from heart disease and who are suffering from heart disease. Both cases, how the cholesterol readings may vary, that we are seeing with the help of this violin plot. This is another popular form to show in which area or in which readings you have higher density of measurements. Like the cholesterol readings here are more common between the range, maybe we can say up to 100 to 400. In this area, the violin plot looks like more dense number of readings. However, in the other case, you can see majority splitted into two clusters. One range is here, other range is on the bottom margin also. So both of them are observed here side by side. So these violin plots also may help you in some type of variable distribution checking. And the last plot I'll create here is one of the most commonly used plot for heat map analysis, for multivariate analysis basically. I'll pass one more detail here. Heat map, that is basically to check correlation between clinical variables. Correlation is one of the most popular analyses to analyze relationship between multiple variables with each other. I hope all of you might be aware about how correlation works on variables. Do you know how we use correlation variable analysis? Okay, for correlation analysis, whenever you are testing it on different variables, I'll just give a general idea about that. Although those who do very in-depth analysis on SPSS, etc. software, they may be already aware how it works. But for the beginner level understanding, generally correlation we have with range of values. One set we take is with, it goes from -1 to +1 in general. +1 indicates high positive correlation between two variables. -1 indicates high negative correlation between two variables. And 0 is the intermediate value that shows null correlation or no correlation between two variables. When two variables are just completely following each other, they become correlated by maybe +1. And this also represents autocorrelation or self correlation of a variable. If we try to check correlation of a variable with respect to itself only, it will always be +1, because that is just a common tendency of any variable. It will always have a correlation of 1 with itself. However, sometime comparing with each other, you may have values between -1 to 1, indicating how two variables are related with each other. So the values may lie in this range when you calculate correlation between variables, and that only help you to understand how they are related to each other. So for this, we can generally use correlation matrices, or in Python, we preferably use heat maps for this purpose. So first thing I'll do here is, as the correlation analysis we can do between numerical variables only. That is not possible between categorical variables. First of all, I'll choose numerical variables from my data, because otherwise there are mixture of variables that we have seen. If I try to apply heat map analysis on entire data in one go, it will give us error that it cannot map correlation between these type of variables, because they are alphabetical sequences, and correlation can be calculated between numerical variables only. So for this, first I'll separate my numerical variables. And what I'll do for that, I'll write here df2 dot select d types, means select data type, and include number only. So this will help me to identify only numerical variables. You can see only numerical variables I have identified from my data, just to help you see how you can create correlation between these numerical variables. So once these are ready, I can put them on a heat map. I'll do that here. SNS dot heat map. And then inside this number of variables, I'll write num variables, that is your numerical type variables. I'll calculate their correlation. In Python, we have directly available function for checking correlation between variables. We call it cor function. And we can also deploy it as it is. Like for instance, I can just run it in this simpler manner. You can have this kind of graph. But to make it more easy to read, I'll add few more features. I'll annotate it and I'll say true. This is annotation. Currently, all these boxes are empty. You cannot find any value inside. When I annotate this, you will find values of correlation also inside. Now you can observe them clearly, that what is the value of correlation, and that is indicated with color markers. By default, this color arrives, but we can also change this color. There are few common options available. So I'll say color map. Currently, we have the by default color map. We can change it to maybe some other option. The most commonly used one is cool warm. So I'll add this, and this is a brighter one that is easier to add into your different research papers also. So this type of multivariate analysis may be useful sometime, and in level 2 course, we will use this kind of analysis in several times just to make selection of features. We will discuss in detail over there that how this heat map can assist you to choose your variable specifically. But here we will just understand quickly how this particular may assist you with basic data analysis, not in terms of machine learning, but in general how it may assist you, that we will discuss. So quickly observe here your variables. As I told you that your heat map may have correlation between ranging from -1 to 1. So that range we are able to see here. Also, I told you that autocorrelation is always 1. So that is why the diagonal elements are always 1. You can see all the diagonal elements are 1, because that shows autocorrelation of the same variable. You can observe this is age with respect to age. So that is why this is autocorrelation. Then resting BP with respect to resting BP. You can see X and Y axis values. So that is why the diagonal variables are always 1. Then second thing in this heat map, observe carefully. This one variable value is equal to this value. This variable value is equal to this variable value. Means there are two triangles available in this heat map. One is your upper triangle, other is your lower triangle, and they are completely identical. You can observe these values, they make them completely identical. So instead of getting confused between entire matrix, you can check any one half of this matrix. In upcoming course, we'll also learn how we can plot it with just one half only, not with the complete details. That type of settings are also available. So we will learn it with one half only. That is easier to understand. And then further, you can check how variables are related with each other by analyzing any one half. For example, if I quickly tell you that how this max HR is related with resting BP, so we can mark it here. This is max HR and this is resting BP. So I can say that they have minus 0.11 correlation with each other, means they are negatively correlated. And although this is close to no correlation, null correlation, that is close to 0, but yes, it is slightly on the negative side. And if I ask you like which two variables look like highly correlated on the positive side, can you see it from the lower triangle quickly? Which two variables look like highly correlated? Although this is not like a very huge correlation close to 1, but still you will see that at least some positive value you are getting. Let me know which two variable look correlated with a high value in comparison to other. 0.4 value, yes, old peak with heart disease, we can call it. So this heart disease value with old peak, at least a positive correlation, we are able to see this with this one. So this kind of general analysis you can do by analyzing different types of variable against each other, and you can understand whether they are just translating each other, whether they have some difference in comparison to each other. And this ultimately helps us to select features for our machine learning model training also sometime, because highly correlated features we prefer to drop any one out of them and other we pass further. Like if they are translating each other completely, then there is no need to use both of them. Then we'll just use any one of them if they are like highly correlated with each other, because they are representing almost same thing in that case. But that point we will discuss further when we will understand feature engineering specifically in a level 2 course. Currently we are just understanding how we can use different visualization techniques to understand relationship between different variables. So that point we are understanding here, that how a multivariate analysis we can do by using these heat maps. So with this, I'll stop here for the last day of the course. We have discussed plenty of things throughout this 10-day analysis, and I believe I may have shared some relevant details with all of you.